Hey friends, how's everybody doing today? Alrighty, happy Wednesday. Alright, let's see. Alright, I think I got that ready. Alright, I finally set some office hours. Thanks for filling out that when to meet link here. So we're going to do Monday, Wednesday, 3 to 4:30 p.m. and 10 to 11 p.m. or by appointment. So if you can't make Monday, Wednesday, 3 to 4:30 or 10 to 11, then feel free to propose a couple times to me, and I'll see if I can make them work with my schedule. I'll do my best here. So let me go and update that here in D2L, so you've got that in the syllabus. Alrighty. Come on. Let's load. Maybe. Just thinking about it. It's gonna be one of those days. Let's try a refresh. It was the Jeopardy music, yep. Oh man. Oh, why is the D2L loading for me? What gives? Oh, I don't need the stream manager open, that's good. I can close all that down. Some of those out. Okay, let's see if this speeds it up a little bit. Close some of this other junk. Hey, look at that. Okay, it did take care of it. Awesome. Alright, so I'm not going to bother like with the version 1, version 2 thing. They're just here, okay? And I did add the source code from the book if you wanted it. It's version 4 of the book. I did find version 4. That's on the black cover here. I did have it. It's just further back on my shelf from last time I taught the class. So when I asked for it for this time around, they gave me the 5th edition. Not realizing we haven't switched to that one yet, because you don't really gain a whole lot changing editions all that often. So, all right. Hopefully, you got a chance to get Project 0 done and in. I think I graded most of the ones that I saw, unless you just turned it in very recently. Seemed to work out pretty well. You folks did seem to have some trouble on the syllabus quiz, though, which confused me a little bit, especially around the answer on whether or not the tutors at the ASC will write the assignments for you. They're definitely not going to do the work for you. So you're welcome to take the syllabus quiz again. That one, you know, it should be free points. Go ahead and take it again if you didn't get the score that you wanted. Come on. All right, we'll take a look at our schedule here. Let's see our tools. I did talk with Dr. Ball a little bit, so he recommended against doing anything with JFX and Scene Builder. So we won't do any GUI-based programs, which is a little sad. Yeah, the Project 0 is just to get your tools up and running. Yep. Making sure that you can get code into D2L, you can send me links to D2L, or no, get code into GitHub, not D2L, submit links to GitHub, from GitHub to D2L so I can grade it, and go from there. All right, so we have chapters 1 through 3 tonight, along with interludes 1 and 2. So we'll talk about generics, exceptions, and the ADT bag. That probably should actually be down a line here, because it's like fits a little better that way. All right, and then we'll finish up the ADT bag if we don't finish it tonight. Next week, we can talk about the efficiency of algorithms. And we're going to have Project 1 tonight. Will be due 6 p.m. on June 2nd. And these ones I can't take late, because on June 2nd, at 6 p.m. I'll go over the solution right here in class. I tend to find people seem to do well, or seem to benefit from watching me solve the problems and see how I go through it. No, so there's nothing wrong with Scene Builder, but because you haven't necessarily taken 2151, your experience with Scene Builder is possibly only based on what you might have done in 1500. And then if you haven't done a lot, we're playing sort of catch up, and that can be unfortunate. So we'll see. You know, I'd like to do some GUI projects because they're much more interesting. I don't know. I'm on the fence. So maybe I shouldn't have said maybe we won't use it. I don't know. Some of these projects are really boring if we don't have a pretty looking interface. So we'll see. We'll see. Maybe for the final project. No, it's not, interestingly enough. It used to be, and then they took it out for some reason, which is sad. Is that voting yes, no GUI, married to pizza, or is that saying like you didn't do very much in 1500, so it's, yeah. Yeah, Hayes, I've heard some stories, and there's some meetings I'll be having with my department about that sort of thing and what happens in 1500 and what we teach, because that's really unfortunate, being it's one of the core objectives of the track. So, okay, that's fine, we'll work with it. So we have the ADT bag tonight, generics and exceptions. So generics are brand new. Exceptions are new if you haven't taken 2151 or it's not introduced in 1500. So those are new topics tonight we'll get to, and then we'll talk about project 1 again, which will be due in 2 weeks. We'll have a project every 2 weeks up to the midterm. And then, hey, Snake, thanks so much for coming on by and for subscribing at Tier 2, my friend. Thank you so much for donating to the Student Scholarship Fund at the University of Michigan Dearborn College of Engineering and Computer Science, where I am both a lecturer and a student. It's a fun story, that is. Data structures is fantastic. This is actually one of my favorite classes to teach. They're just so interesting, I find. Yep, so every 2 weeks we'll have a project now, and these will be worth more points. These are like real projects. We'll have a little GitHub link to get you a repository. You'll put your code in the repository. You'll submit me the feedback pull request, and we should be in good shape. We get to the midterm. We do the midterm. That's the only thing we do that week. And then we come back. We start working on the final project and pick up the last couple topics here. Okay? Depends on the project. So somewhere between 10 and 20 points usually. Remember, the points only really matter within their categories. So the project's category makes up 35%, the final project makes up 40%, quizzes make up 10%, and midterm 15%. Okay. Awesome. I got that. Should be in good shape. Oh, it finally loaded, of course. Yep. All right, let me fire up NetBeans here. Talk a little bit about generics, exceptions, and the ADT bag. And ADTs are, fancy term for abstract data type. That's what we're studying here. So we're looking at what are ways that we can store data. And we're all about storing data in memory. Oh my goodness, D2L just is not working for me at all today. That's really sad. But that's okay, maybe NetBeans will. So again, I'll put all of the code that I do here in the course repository here. Hey, thanks so much, Snake. So let me find like 2353. Here we go. So I'm going to put all of the code into this folder. So anytime I start a new project, I'm going to put it in this folder. And if I don't know where it is, I can do the Show in Explorer. It's just my computer that's slow tonight. I don't know what's going on. What's that upset about? Yeah, you can clone my repo if you want, for sure. Yeah, NetBeans apparently is a hog right now. Oh, and anti-malware. That's fun. What is NetBeans even doing that's using up that much CPU? Come on, NetBeans. See if it settles down here. Alright, that looks a little better. Still, for not doing anything, 10%. Okay. It's calming down. Ah, no, Windows Defender is actually halfway decent. Or, I don't know. I prefer it to other antivirus tools anyway. It's halfway decent nowadays. Alright. Cool, so I'm going to start up a new project. And I'm just going to put it in this folder. Right, this is my repository folder. Anything in here goes in, right, and will be tracked by Git at the line level. So Java with Ants project, put it in this 2353 path. So I just like to copy paste. You can also use this browse option here, but you know, if I can copy paste, I find that a little easier. This is ADT bag. Yeah, Windows Defender is the anti-malware. And as soon as I make the project, my GitHub client should say, oh, hey, there's a bunch of new stuff in here. Right? These build files, that's all fine. Those are all come along with the project. Right? Build XML, properties, project, that's all fine. And I should get a Java file here in a second, if NetBeans will cooperate with me. There we go, adtbag.java. Okay, and I'll take some of these comments out. I've really got to change that template. I keep forgetting to. All right, give it a save, and now I should have a Java file in here as well. There we go. Again, you want all of this stuff to go into GitHub. This is all the stuff that goes in source control. All the stuff we need for the project and the Java files themselves. All right, so I'll just say bag, ADT bag started. Started. Probably don't need to yell at you. Bag. There we go. Commit makes the snapshot of the folder at this point in time on my local repository, and I'm going to hit push to synchronize with the source or the central repository on github.com. That's the whole process. Now, if you work in pairs, you have a little bit more of a push and a pull. Pull will synchronize from the central down to you. Push will synchronize from you up to the central. It depends on the order of changes. Hey, cool. Thanks for following. I'm out of coffee, so I switched to Coke Zero. We'll see. Needs a lot of ice, though. I forgot to put it in the fridge. All right. So the first thing we're going to do is we're going to write something called an interface. Have you folks ever heard of an interface before? Did you touch on that in 1500? When you looked at abstract classes and interfaces? Or is that only in 2151? So it's not a class, it's an interface. Okay, 2151. That's what I thought. So an interface is essentially a contract. It's saying you're going to have a bunch of methods that do something. That's all it is. And then you can implement interfaces in your classes. You should have talked about inheritance, where you inherit from a class. So you don't inherit from an interface, you implement an interface. So it's a little bit different. With inheritance, you can only inherit from one parent class. With an interface, you can implement as many interfaces as you want. So no big deal there, one way or the other. Okay, and then what we're going to do is we're going to introduce this idea of generics. So a generic is, you know, they should have talked about inheritance in 1500, but really done a whole lot more with it in 2151. So a generic type, remember when we use something like the array list, right? We said, hey, I want an array list of type string. We'll call it, you know, I don't know, names equals a new array list. Like that. And then, yeah, we want to import array list. For this little diamond operator, greater than less than sign, this means array list can be of any type. So the type here, we're declaring what it is. So in the array list class itself, it uses a generic type because it doesn't care what type you use. You just tell it what type it's going to be, and then it knows to use that type. So we use this thing called T here inside the diamond operator. This is a generic type of T. So you can give it any type that you want here. So when you declare a bag, it's a bag of a given type. Just like an array list, it's a bag of a type of string or integer or some other kind of object, whatever you want it to be here. So our bag interface says, you just tell me what type it is, I don't care, and I'm going to use that type everywhere. So now T is a special, it represents the type that is declared to be. So it's the generic type. So I can use T in my methods. So in an interface, the only thing we define, essentially, are public methods. There are some exceptions to that, but we're not going to. So we're only going to do public methods. So we're going to say these are things that our bag should do. And if you think about a bag, right? Let's see, I've got one right here, actually. A bag. You put things in a bag, you take things out of a bag, but there's no real order to the bag. Right? Probably, I mean, this one you can sort of order them because it's not a very large bag. But you put things in, you take things out, and then, you know, in terms of things that the bag knows, it can probably tell you whether or not it's empty. it can probably tell you how many items are inside the bag. So our author, what is his name? Carano? 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 I'll say Carano. Says to kind of imagine a grocery bag, right? We put groceries in the bag. We know we take stuff out of the grocery bag when we unload until it's empty, and then we crumple up the bag and do something with it, recycle it, use it to pick up dog poop. I don't know, whatever you do. Line small trash cans, something. So methods that our bag will have. So if you're going to implement this bag interface, you need to do the things that a bag does. So we're going to have a public int for get current size. And all we do is we define the method header. So this is a method header and then a semicolon. There is no implementation in interfaces. So an interface just defines what the methods are. Okay, so we can get our current size. We can figure out whether or not we're empty. So maybe a Boolean is empty. It's empty, maybe. How about a Boolean for add? So if you want to add a T item here. So T again represents the type that has been declared as. So you can add something. We'll just call it item here inside the method. Mr. Carano calls it new entry, and I always get upset by that because I don't know. Sure, it's a new entry, but item. It's an item you want to add. I prefer item. So I'm going to do things a little differently than the book, just ever so slightly, and I'll try and call those out, but my code won't look exactly like his. All right, and then a T. So we're going to return a type of T in this case for remove. So if you want to take something out of the bag, I'll give you a type of T. Jack, is that my phone? Thanks, bud. I love you. All right, it's all done watching YouTube. So remove then is just you reach your hand in the bag, you take something out. You don't know what it's going to be, whatever's on top probably. And then we'll have a Boolean for remove a given item. Posture check. Thanks for looking out for me, code. Appreciate it here. Let me get my little backboard. So if you want to remove an item from the bag, a specific item, say, hey, reach in that bag and pull out that can of soup. Sure, you tell me what item it is, and I'll tell you true or false, yes, it worked or not. Right? If I don't have the item in the bag, I'm going to tell you false. Okay, and then how about just a void method for clear, like just empty the bag out. Just reset, essentially. So this one we don't really use in that bag metaphor, but this will clear out our bag data structure here. So all the items in it just get thrown away. How about an int for get frequency of a T item? Like, tell me how many cans of soup are in that bag here. And a public Boolean for contains a T item, whether or not that item is there true or false. Right? How many are there? Are they true or false? And then a way for someone to interact with the entire bag full of items at once, we're going to say, hey, a T array, no, just T array, there we go. We'll call to array. So I'll return an array of type T to you of all the items inside the bag, and you can do something with them. All right, so this way we can let someone kind of inspect what items are inside of it, open it up, that sort of thing. But essentially you will interact with it by adding and removing something, or removing a specific item, counting how many of one item are in there, whether or not a particular item is in there, if it's empty or not, how many items are in there. Right? And this defines anything that implements the bag interface, then will have these public methods. So we're going to look at two different implementations tonight. We'll look at writing a bag with an array, and we'll look at writing a bag with linked objects. Linked objects are really fun, but they're a little confusing. It takes a little bit of time to wrap your head around it. Okay, so this is our bag interface, a generic type of T. And remember, with an interface, you can't actually implement it directly. Right? I can't say, hey, I want a new bag interface, because there are no definitions here. It doesn't know what to do. It just wouldn't do anything for us. Okay, so we need to write a class that implements this interface. But the reason we like interfaces is this behaves as the contract. So any way we want to create a bag, we can interact with the bag interface contract. This is the abstract interface here. So we know that there will be methods with these names that will do certain things, whatever we want to do with them. Okay, so that's the ways that we can use our bag. And now we don't actually have any implementations of bag yet till we get to the next chapter, which is a little funny, but that's okay. Sure, we could do that. So with the bag, you can have essentially as many things as you want. We can put a cap on it if we want, or we can put unlimited, essentially. We got a couple options there when we go to implement it. But there's another type. Right? So a bag, you can put as many things in as you want. There's another thing called a set. And if we talk about a set of items, that means they're unique items. It does not allow duplicates. So this, like, get frequency of is kind of silly in a set here, but we might also have a set interface if we want. So we could write a set interface if we wanted something to implement a set. And a set, again, is just a single item of each is allowed at a time. So you can't have any duplicates. So you have a little bit less than you have the bag, because you don't need to get the frequency of. Most everything else is there. Yeah, current size, entry, add, remove. Yep, those are all fine. So we would do almost the same thing here for set. So I'm just going to copy paste. And we'll write that interface too. So write a new Java interface. This is the set interface. And does all the same things, except for get frequency of. And it's not a bag. There we go. Look at that. Set interface of type T. Okay, we can get the current size, we can figure out whether they're empty, we can add something, we can remove whatever's on top, we can remove a specific item, we can clear, we can figure out if we contain something, or we can turn ourselves into an array. Okay, so that's our set interface. So again, depending on what we want to do with our operations. And now there is actually an interesting, the Java API has its own set interface that you can use as well, instead of writing your own. But it doesn't use a generic type T. It treats everything as object. Okay, if you remember back to talk about inheritance, everything implicitly inherits from object, every class that you write. So you can treat everything as an object instead of type T, but then you have to do a bunch of casting, right, to turn it into your specific type. So T and generic types are much nicer because you don't have to do any casting. So we'll take a little look at that while we talk about generics. Oh, hey, Case. So I'm going to write another class here for fun. Sorry, not an interface, a class. And we'll call this one, this is, I don't know, generic test. We'll say generic test of type T. And maybe we'll have a T first. I will make this a private T first and a private T second. And we'll write a constructor. Generic test given a T first and a T second. Yeah, and this first equals first, and this second equals the second. So I don't know what type this is going to be. I just know that I'll have two of them. And then how about we add a toString, right? Override public string toString. Right, and we're going to return first dot toString plus second dot toString. Yeah, that's really ugly. Hang on, let's do a little format. So we'll do string dot format with I don't know. It's going to be a string, right? So %s here for a string substitute, or maybe we'll say first colon is that, and then second colon is another string substitute. How about that? That looks a little prettier. And we don't have to do any concatenation. Right? We can just add these in here. Okay. Oh, I'm missing a parenthesis. There we go. All right, sorry, that's a little long. I had to slide over. My font's a little big, but that should be okay. So this one's a generic type T, right? We can get toString, sure, perfectly fine. So if I want to use my generic test here, right, so we'll make a generic test of type, how about we do string? We'll do string as well. And we'll call this one, I don't know, pair of, or we'll just call it class. Course. How about course? Equals a new generic test. And we're going to give it two strings. We'll say CIS, and then we'll say 2353. Right? We give it two of the type here, because that's the constructor. The constructor says, you give me two types. And notice this is an empty diamond. It's just a shortcut. If you tell it what type it is here, you don't need to include it a second time. Java's smart enough to figure it out that you probably mean string because you told it string initially. All right, and then we can say course, because that should call the toString method. All right, we'll give this a little run. See if we get out CIS 2353. Oh, first and second. All right, so the first item was CIS, second item was 2353. That works okay. Let's do a new class without the generic type. This is, we'll just object test. That's not my best names here, but that's okay. So if this is not a generic type here, we'll have a private object first and a private object second. And then we'll make a constructor, public object test. Test. Oh, you know what? I don't actually want to do that work. I want it to write for me. So I'm going to insert code, go to insert constructor that takes a first and second. Right, so that's my first to my first, my second to my second. And I'm just going to copy paste this over here, right? This toString. We'll put that one in as well, first and second. And see if we can make an object test. We'll make an object test, other course equals a new object test. And we'll say, how about CIS 2151? And we'll print out our other course. See if this one runs. And we still get first and we get second. Sure. But now, if I made a mistake here, and maybe I did 2151 instead of a string here, object test is going to be fine with that, right? Because integers can be held in the integer class type, which is perfectly fine, and it still works here, but I can't do it up here with the generic type. My generic type is going to yell at me saying, oh, hey, that doesn't match. It's object T, right? Incompatible types. Inference variable T has incompatible bounds. Equality traits string, lower bounds, integer string. Where T is the type variable, T extends objects declared in class generic test. That's a big mouthful, but it's saying, hey, you don't match your T. You're the wrong type. So with generics, you get compile time type checking. With objects, everything's an object. Sure, anything can be thrown in an object. Okay, so that's the big difference here. With a generic type, when you declare a type here using generics, you get compile time checking. And also, we don't have to do any casting, right, which is nice. That's a good benefit. Okay, so I'm going to add a note here. So with generics, compile time checking of the T type. Objects. Everything is an object. Oh, buddy, I got a book on my lap. I got a book in my lap. You want to come up? All right, come on. He freaked Merlin out, tried to jump up, and there was a book there. Do you want to come up on my lap? All right, okay, that hurts me. That hurts. Yeah, you got sharp claws, baby. You want to say hi to everybody? You want to say hi? Here, you came up. You can say hi. Merlin, say hi. He's my baby cat. Yep. He is 3 months old and a couple days. Yep. Now, well, thank you. He apparently wants the condensation on my Coke Zero jar. And now his sister's getting jealous. Uh-oh, this might hurt my lap. All right, buddy. Okay, so with generics, we get compile time checking. With objects, we don't. So that's one big benefit there. I'm going to put this back because it's probably better this way anyway. But we just say, hey, if you want something generic, you give it of type T, and then you get to use this T anywhere else in your code. Hey, that's so cool. Ochoa, thanks so much for subscribing and donating to the Student Scholarship Fund at the University of Michigan Dearborn College of Engineering and Computer Science, where I am a lecturer and a student. That's so cool, you folks. I might actually be getting close to Twitch sending me money eventually. That'd be fun. Okay, so we made some interfaces. We have this bag type here, and it uses generics. But we don't actually have an implementation of our bag interface yet. Are we okay so far? With the interface, again, it's new. It just says, hey, you will have all of these methods. And we'll go and implement this interface shortly, and hopefully that'll make the interface make a little bit more sense. So I'm going to make a new Java class. We are going to be, let's call this one, I don't know, how about a bag array here. And if you want NetBeans to do some work for you, you can tell it what interface right here, or we can do it in just a second. I never usually fill this one out. I'll do it while I'm typing, is usually what I'll do. So I'll say this is a bag array. Or should it be array bag? Bag array? I don't know. Okay, so this class now will actually implement that interface, and it is that exact word. We say implements, there we go, no, implements, my goodness, spelling is hard. Typing is easy, spelling is hard. Implements bag array, on bag interface of T, and this is a bag array of T as well. And now we get a nice big fat red line. It says, hey, bag array is not abstract, does not override abstract method, ... in bag interface. So we say we're implementing the interface, but we're missing all of the methods. So what we can do is we can click on it, we can say implement all abstract methods. We get a bunch of code. Right? We get all the method headers with the @override tags. Now, they're going to throw exceptions, which is okay for now. Right? We'd say we don't do this. It's an unsupported operation. Not supported yet. Sure, that's all well and good. Okay, other things our bag array needs, right? Now we need some private attributes. So we probably have a number of items, right? Because we know how many items are going to be inside of this bag, right? We're going to need a place to store, so a T array for items. Nope, items. There we go. So a T array, so type of T, an array of items here. And actually, it might even be easier to use an array list. That sort of defeats his purpose here, though. So let's stick with array. Array list is much easier, but we're going to do it the hard way because that's what he does. And now I'm feeling a little bad about it, but that's okay. So of the number of items, we'll have our items, the actual items themselves. What else do you think we need to track? That's probably good for now. Right? We can do that. He does go through and it has a default capacity. So if you don't tell the bag how big it should be, we could default it to a given size. And maybe we do that. So I don't know. How about a public static final int default capacity? I don't know. How about 25 items? I don't know. So if you don't tell me how many items, I'll assume it's probably 25. And again, this one we can make public static and final. Say it's 25 all the time, no matter what. And maybe we move that up here to the top. I don't know. I'm not too particular where you want to put your static final variables, but that's probably fine. Why is there a semicolon there? That's weird. Okay. So now we should write a constructor. So a public bag array. Right? That takes an int, or how about a no argument constructor first? We'll say my items equals a new array then. New T array. Nope, T array. Size of, how about default capacity? Should we do that? Uh-oh. Generic array creation. So it knows it's a generic type, but the problem is Java doesn't like this. For whatever reason, it gets confused. So what we need to do is we need to create an array of object here, and we need to cast it as type T, or T array, right? T array, I think. I don't know why this is preferred, but this is what we have to do. So can't create a new type T cast object array. I don't know. That's just what Java does. Sure. So we'll say, hey, it's a new object array. Oh, by the way, it's really type T. Okay? For whatever reason. So now we have our items of default capacity. Now, how about if we don't have a default capacity, if we have a bag array given an int for like initial size, or I don't know, size, or max number of items, I don't know, size is probably fine, max number of items, something like that. That's okay. And the other things our constructor needs to do, remember, you can't be on the keyboard. You can't be on the keyboard, baby. Right? We should say my number of items is 0. Right? Start with 0 items. So if you tell me what the size is, again, we'll do the same thing here, but now I'll use the size. And now I have the same code in here twice, and I'm feeling bad about myself, right? And you should feel bad about yourself, right? If you have the same code in there twice, you can do better. We should make a method, or essentially use that method. So I just need to call this given default capacity. Remember, this will call your constructor a parameterized constructor. If I say this default capacity, it will call the constructor that accepts an integer, which is this one right here. Right? This is my reference to myself. So I'll say, hey, call myself, but this one here. This way I don't need to have this line in twice or this casting in here twice, and it makes me a little happier. Again, probably not too big of a deal one way or the other, but, you know, this is probably better. Okay, does that make sense why we would want to use the this operator, just so we don't have to do this twice? Okay. And now get current size. That was pretty easy, right? It should be number of items. Okay. Is empty should be easy as well. Now, I see a lot of people do this. I'm going to show you the wrong way, and then I'm going to tell you why it's silly. They say, if my number of items equals 0, return true. True. Oh my goodness, I can't type. True. Else return false. And now I applaud your use of curly braces, because yes, you should always use curly braces, even if it's a one-liner. I don't remember if I told you folks or the other class, or I tell all the same stories to everybody, I'm sorry, and the same jokes, which is unfortunate, that back years ago, the Safari browser had a vulnerability that broke SSL encryption. That's a pretty bad thing if your browser can't securely connect to websites. That's pretty bad. And the root cause was one of their wonderful developers there, and, you know, mistakes happen, it's okay, was not using curly braces after an if statement. So they meant to have 3 lines of code run, but only one of them ran if the if statement was true, and the other ones always ran, which turned out to put a big hole in SSL if you did the right thing. So I'm a strong believer of always using curly braces because it never hurts. Right? It's only ever going to be a good thing. And they're not hard to type. But anyway, doing this is still wrong here because this is redundant. Right? This right here, number of items equals 0, is already a Boolean, true or false. So instead of saying if true, return true, else, you know, which means false, return false, we can just say return number of items equals 0. That right there, my friends, is already true or false. Right? Because we don't need to say if true, return true. We can just say return the thing that's true or false. We okay with that? Make sense? I think that would make sense. Cool. Thank you. All right. So we can check if we're empty. We can get our current size. Sure, we haven't been able to add or remove anything yet, though. But that's okay. We'll get there. Okay? So, you know what? He has this as private. Private static panel? Sure. I don't know. Follow along, Mr. Carano. He has it as private. We'll leave it as private. I guess you probably don't need to access the default capacity anywhere else outside the class. So it probably makes sense. We'll leave that private. Okay? So to add an item then, right, what we're going to do, we're going to take that items collection, that items array, right, at index of my number of items. Number of items, and we'll assign it the item. Then I'll take my number of items, plus plus. Now, I know some of you are going to say, well, you could just put the plus plus right here. I find that awfully confusing. I don't like that. Just, I don't know. I would rather, this is a fixed number, now I'll go change it. But that's just me. But what is this whole Boolean thing? Is it true or false? Well, I guess we need to check to make sure we have room, right? So we can check if my number of items is less than what, the size of my array? Yeah. Remember, my array will have indexes from 0 up to the size, but not including the size. So if number of items is the size, right? So really, I guess I could say if it equals items dot length, we're going to return false. So if we're already at capacity, we'd have no more room inside the bag. You try and put another item in the grocery bag, it's going to rip. The bottom will fall out. Your groceries will go everywhere. People will be sad. We'll return false. Okay, no good. Otherwise, we'll go ahead and do it, and we'll return true. Life is good. True here. Okay? So if there's no more room, tell them no. Otherwise, go ahead and add it and say, yes, this worked. Okay, so that's how we add things. To remove something, well, which one do we want to remove? Well, how about we just remove the thing at the end? Right? There's no rule. We can remove the beginning thing, the middle thing, the first thing, the last thing. I think removing the last thing is probably easiest. So we're going to take the T item is my items at index of number of items minus 1. Right? If I have one item, it's at index 0. Okay. Then we can go set by items equal to null. Right? This null is a special operator saying, hey, you're empty, you're nothing, gone, nada, zip, zilch, nothing there. So we're going to remove our reference to it. Because remember, if you are holding on to a reference to something, the Java garbage collector cannot free up that memory. So if we've asked for a bunch of memory to store a really, really, really big string or something, and then we go remove it out of our bag, but we forget to actually take it out of the bag and don't remove that reference, Java's going to hold on to it forever. Okay? So you know what? Actually, I like this. Let's do this instead. We're going to take number of items minus minus first, and then I don't have to do this minus minus thing, minus 1 thing. I like that. I think that's more fun. And then we're going to return the item. Okay, how's that sound? That sound okay? Cool. Now this might cause some trouble if our array is empty. We'll get an invalid index or array index out of bounds exception, which is probably not what we want to give somebody. Right? So maybe we check first. Maybe we can check and say, hey, if is empty, because we already know how to define whether or not we're empty. Now, we're going to talk about exceptions. We'll get to the interlude here in just a minute, but an exception tells the person who calls your code that a bad thing happened. They did something wrong, right? Remember, when we design classes, we have a nice noun with all of its attributes, all of its public methods, right? So we're encapsulating all the details. All of its attributes are typically private. We expose public methods for ways that we want this object to be interacted with. And then the object is responsible for maintaining its integrity. So if you're going to do something that would violate the integrity of the object, we need to yell about it. And the only way that our class knows how to tell someone else that something went wrong, it's not system.out.println. Because remember, there's no guarantee that our class is going to be used in a console application where anyone is going to see it ever. So classes should rarely ever system.out.println. Right? The only time we want system.out.printlns are essentially in the class that has a main method, because this one is you're probably running at the console again, or in a GUI application, right? Main will launch a GUI and all that sort of thing. So the code that deals with interacting with the user needs to be the one that spits stuff out to the console, reads stuff from the console, prints stuff on a GUI, gets interactions from the GUI, is a web application, right? Gets web information or not, or mobile application, that sort of thing. Our class here could care less how it's being used. So the only way we have to communicate is by raising an exception. So we say or throwing an exception. We say throw a new, I don't know what, invalid. What is it? Invalid. There's probably a good one in here. Valid object exception? No. What's a good one here? What does Mr. Carano use? Let me see what he has. I thought I looked at that before. Where is it? Where's his exception? Oh, goodness. Check. All right, we're getting there. Invalid. Oh, goodness. Missed it. Invalid. Oh, security. He uses a security exception? I don't like that. Invalid. Or how about invalid? Oh, man. Which one do we want? Invalid. Class exception? No. Now, there's so many arguments here we can use. Types, stacks. Is there an argument? Legal argument exception? I don't know if that's the right one. That one's not too bad. Legal argument exception? Tag is empty. I don't know. We'll try that. I guess it's not really an argument. I don't know. Legal. What else do they have? Illegal state. Okay, illegal state. There we go. I like that better. An illegal state exception. It constructs an illegal state. Oh, it was telling me about it, wasn't it? Method invoked at an illegal or inappropriate time. Java application is not an appropriate state. Okay, sure. We'll say that one's fine. So when you throw an exception, your code stops. So nothing past here runs. It's kind of like a return, and it forces the caller of the code to handle the exception or crash. So it really gets their attention, because when you crash your program, it's just bad news bears. Right? No one wants to have their program crash. And handling exceptions is the way to keep yourself from crashing. That's the right way to do things. Okay? So if we don't throw a new illegal state exception, we're okay to remove something. I think that's probably good. All right? Now this one is different, because this one's a true or false. We want to find a particular item to remove. Okay, so we need to loop through all of our items. So we'll say for t item in items. This is the. Oh man, I want to call it item. I'm going to call this item to remove. There we go. The item in the items collection. Right, this is an enhanced for loop. It's going to go through each item, call it item inside the loop. So we can say if item equals item to remove. And really, we probably want to use the dot equals method here, because I don't know what your generic type is, how it's been defined. But if you've defined an equals method, this is more appropriate to check for equals. Remember, the double equal sign is only ever going to check to see, do you have the same reference in memory? Where if we write a custom class, we can say, hey, my class should be equal to if you have these same sets of values. Okay, so we'll check, hey, if the item is equal to, let's return true after we remove it. But we have to remove it first. If we've gone through all of our things and we haven't found it, we're going to return false. So what do? We need to take it out of our list. Right? So we're going to take our number of items. Oh, shoot, we can't use t item. We can't use this enhanced for loop. Now I'm feeling bad. This is, when you do this sort of loop, it's a read-only loop. I forgot. So we don't actually have access to change the array. So forget that. We're going to go back to for int index 0. Index is less than my number of items. Index plus plus. And if the item is equal to my items at index here, then we can go and do something. Okay, this is a better check. Sorry about that. Because we need the index notation in order to change things. So I'm going to take my number of items. I'm going to go minus minus. So we've taken the item out. Now the last item there, right, is at index of number of items. And I'm going to take the items array at index, and I'm going to assign it, right, instead of putting it null like we did up here. So we just made the last one null, so there's room to add the next one. This time we're going to overwrite it with the items at number of items. Okay, so if I found it, I'm going to back off my items here, take that items index, overwrite with this last one here, and then return true. Now the only downside is if this was the last item itself, we're going to be in trouble. Right, because we didn't actually change anything here. So we need to do one more little check, right? I guess we should say if, no, that's fine. So if index is equal to the number of items, then we'll set items at index to null. You know what? Let's do that first. Let's do that first. There we go. That way we don't have to do it with an if. We'll set it to null, and then we'll overwrite it with this one. And this one might be going to ban the word item. Okay, I will give that a shot. 27. I might have to change some of my variable names here. But items is okay, right? Because this is the plural version. That's a different word than the singular word that I'm not allowed to say. So I can say items. So items at that index, where it matches, we're going to assign it null, and then we're going to overwrite it with what is at the new end. All right. So remember, if we have 5 items, we have indexes 0, 1, 2, 3, and 4. There is nothing at index 5. So I'm going to take my index down by 1, my number of items down by 1. At 4 is the last thing. I'm going to take the 4th thing and put it on top of the original. I'm going to move it. Oh, but now I need to make that one null though. Oh, bummer. Okay, this is okay. So we don't need to null it out first because we can null this one out. So if they are the same, we'll null it after the fact. Okay, that'll work. So we're going to copy the last thing, and then we'll put the last thing as null because we've moved it to this one. If it happens to be the same thing, then, oh, too bad, we're moving it anyway. There we go. That ought to work. Okay? How's that with remove? So to remove a particular item, if we find it, take the last thing, put it in its place, right? And then we null out the last thing. To clear, clear, we just get rid of everything. That one's easy. That is items dot. Isn't there? I thought there was a clear. Shoot, not a clear. My items array is not a clear. Seriously? That's depressing. That's all right. We can copy Mr. Carano. He won't mind. Here's my clear. Okay. Huh. Sure. So he says while wait, while not is empty, remove. Remove an item. Remove the last, remove the last, remove the last, well, as long as we're not empty. Sure, that'll work. Right? As long as we're not empty, keep on removing things, and we know we're just removing the last thing. Go for it. Great. Okay, we all right so far? Oh, it's get frequency of. Here we go. So we're going to have an int count, or let's go frequency, right? Frequency. Starts off at 0. And for int index is 0, index is less than number of items, index plus plus. Am I adding number of items? I am adding. Good. And I'm subtracting and removes. Good. Ooh, when we're done, then we need to... Oh, no, remove should take the number of items down by 1. Good. It's afraid we didn't reset number of items. We're good. If my items at index dot equals the item, we'll take my frequency plus plus. When we're all done, we'll return frequency. Okay, give that a little format. All right, I don't need these imports. Those are silly ones. There we go. And this is a quick counting. How many times is it there? What's up, Ben? I'm going to take a break in like a couple minutes. Okay, so now contains, we have options for contains, and this was actually an interesting discussion Mr. Carano has in the chapter. The easy way to do this, and it's the wrong way, and hopefully it's a little bit obvious why it's the wrong way. We could say if get frequency of the item is greater than 0, return true. Or, right, remember, if you're checking if something's true, don't do that. Just return that thing, right? Get into that habit, right? This is a Boolean. You can just return that true or false. Now, why is this the wrong thing to do? So just imagine, and this might help you remember or figure out why this is the wrong thing to do. Imagine we have a bag with like 100,000 items. And we find, you know, the thing we're looking for is in there, maybe 1 in every 10 items in that bag happens to be this item. Why is this going to be the wrong thing to do? Remember, get frequency of is looking at every single item. Hey, Scout. So if we look at every single item to count how many that we have, we're doing more work than we need to. I think that should be contains. I think it should be contains. Let me refactor, rename that here. I think that should be contains. Yes, that's fine. Okay, so it should have fixed it everywhere, even in my bag interface. Yeah, contains. There we go. We got our S. And we should change that in the set interface too. Contains. All right. So why is it bad to look at every single item to see whether or not we contain something? Remember, if we have 100,000 things, we're going to look at all 100,000 things. Even if we found it in the very first one, the very second one, or the very third one, we're wasting time. Right? We're not being efficient. So we don't want to use this. I mean, it's quick and easy, but it's wrong because you still will look at 100,000 items if you have 100,000 items, even if it's the very first thing. Right? If you don't contain it at all, sure, then it didn't hurt to look at all 100,000. But if you did contain it, we want to stop as soon as we find it. So we're just going to go through and check here. If it equals, we're going to return true. If we got to the end and we didn't do anything, right, we'll return false. Because if we returned, we never get here. Now, Mr. Carano is more of a fan of while loops that with a short circuit. I'm not a fan of that. I would rather just say return true. Some people think it's ugly to have more than one return in a method. Sure, that's a fine argument to make, but I don't buy into it. So I'll say, hey, if it equals, return true. We contain that item. If not, false. Right? So if it's the very first item, we look at one thing out of the possibly 100,000, and we're done. So this is more efficient, which is why this is better. Right? We want more efficient code. All right, and then the last one we have to cover here is the to array. How do we turn ourselves into an array? Now, what we don't want to do is return items. This is really bad, right? Oops. Really bad. You know why this is really bad? Because this is our private data member. And if we give them access to it, then they have direct access to all of the items. They can add to them, they can change them, they can subtract them, right? not subtract. They can remove them. They can null them out. Right? We don't want to give them access to our internal storage, our internal data storage. That's a bad idea. So what we want to do is we want to make a copy for them. Okay, so let me go grab this one here. How does he give his copy? Where'd he go? There's a nice shortcut. I'm trying to see what his shortcut was. How did I miss that? Oh, all right, sure. I guess I didn't have a shortcut. So don't do this, right? So don't give access to your private data member. Okay, what we want to do instead is we want to make a new array. So we'll have a T array. This is, I don't know, to return? Sure. Return equals, and then we have to do the silly casting thing, T array of object array size of number of items. Right? And then we'll say for index 0, index is less than number of items, index plus plus. We'll take the toReturn array at index, and we'll assign it the value of my items at index. Right? Just copy them over, and when I'm done, I'll return the toReturn array. Oh, he calls it result. That's probably prettier. How about we'll do result? I like that. What did I do wrong here? Object array. Oh, too many square braces there. Object. Object. Am I typing it wrong? I must be typing it wrong. Object. Ah, new. New. T array of a new object. There we go. Need that new keyword. All right. So we make a new array of type T, given the size, number of items. And again, they don't need the oversize, right? Because our items storage even has more items anyway. We got a bunch of nulls at the end. So we make them empty. And we'll return that result. Does that make sense for our copy? So this way we give them back a copy of the items, not access to our internal items. Right? Don't let people touch your private data members. It's good advice. Solid advice. All right, I've got 7:06 on the clock. Been talking here for a while, so why don't we take a little break? We'll pick it back up, talking more about exceptions, and then, chapter 3, looking at a list bag. So we're cruising, so please stop me, shout at me, tag me, whatever you got to do. Thanks, Yuki. Hope the move's going well. So if it's going too fast, let me know. Just kind of cruising through. We're implementing the interface using a bag, or an array, for this bag interface. So again, the person using this now would declare a bag array, and this one they could use. So we'll get back to using it here in a little bit. We'll take a little break of using it, and then we'll go back to writing it with a list of linked objects, okay? So I'll put some music on. We'll come back in about 10 minutes or so. We can go from there. Is that too loud, by the way? How's the volume on that? Put on my break screen here. Right, and that is going to be, we'll say 7:17. Take a little 10-minute break. I redefine any definition you got. I am the tiger, I'm making steps to the top. The flames, I whip it up, you just gotta hand me the rock. Take a seat, you cannot stand it. All I know, the flow harder than a scotch bunny. Don't try study me, you cannot manage. This ain't what you want, bitch, I'm a fucking phenomenon. This ain't what you want, bitch, I'm a fucking phenomenon.
head spinning. I'm known as spit vicious. Release bombs and go tick, tick, boom. You blow me, that head missing. I'm a phenomenon. Stacking cheese like it's Parmesan. 8 different flows, call me Octomom. I'm moving fast like the Autobahn. And I'm independent, so I'm not your fucking starving like it's Ramadan. Sick, twisted, gifted, can't copy, printed, can't hold me down. I shape shift, I'm liquid. I killed this beat, I might get convicted. They know how I move, it was predicted. Persistent, spoke it into existence, so consistent, no assistance. Hear me once, become addicted. If I rap it, then I live it. There's no cap when I be spitting this.
This ain't what you want, bitch, I'm a fucking phenomenon. This ain't what you want, bitch, I'm a fucking phenomenon.
When I see you dancing, I'm like, hola, 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 hola. With your move fancy, make me wanna hola, 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 hola. I got your attention, spending that moolah, 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 moolah. I'm a drop popping, pocket, swola, 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 swola. Swola, swola, swola. Swola, swola, swola. When I see you dancing, I'm like, hola, 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 hola. With your move fancy, make me wanna hola, 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 hola. I got your attention, spending that moolah, 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 moolah. I'm a drop popping, pocket, swola, 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 swola. Your attention, spending that moolah, 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 moolah. I'm a drop popping, pocket, swola, 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 swola. Swola, 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 swola. Swola, 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 swola. Swola, swola, swola. Swola, 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 swola.
I'm getting freaky. Everybody know I'm a visual. Yeah, I kill it cold like a criminal. I'm everybody's type, but nobody can deny. Cause you know I get it, 나는 아무리 봐도 I'm getting freaky. Yeah, I'ma bring the crazy. Get that freaky, freaky on. Get that freaky, freaky on. Getting freaky. Get it right, get it right. Get that freaky, freaky on. 신경 끄고 다 같이 getting freaky. Yeah, I'ma bring the crazy. Get that freaky, freaky on. Get that freaky, freaky on. Getting freaky. Get it right, get it right. 상관하지 마. on the top, the top winner. I'll be on the top, top killer. I'll be on the top, 'cause I own it, know it, I'm alright. I'm getting freaky, yeah, I'ma bring the crazy. Get that freaky, freaky on, get that freaky, freaky on. Getting freaky, get it right, get it right. Get that freaky, freaky on, 신경 끄고 다 같이. Getting freaky, yeah, I'ma bring the crazy. Get that freaky, freaky on, get that freaky, freaky. Getting freaky, get it right, get it right. 상관하지 마. I'm getting freaky, yeah, I'ma bring the crazy. Get that freaky, freaky on, get that freaky, freaky. I'll be on the top, top killer. I'll be on the top, the top winner. I'll be on the top, top killer. I'll be on the top, 'cause I own it, know it, I'm alright. Get that freaky, freaky on, get that freaky, freaky, freaky. Get that freaky, freaky on, get that freaky, freaky.
Spilled your drink? Bounty picks up spills quicker, and each sheet is 2 times more absorbent, so you can use less than the leading value brand. Bounty, the quicker picker-upper.
The e-tron fleet of all-electric vehicles from Audi is ushering in a new era in mobility. Engineered to deliver the exhilarating performance you expect from Audi, with an eye towards a more sustainable future. Experience e-tron at your local Audi dealer today.
At Kroger, everything we sell is guaranteed fresher than fresh because our associates constantly check to make sure everything is at the peak of freshness. That means peeking at the peaches, spying on the steaks, and delving deep into the dairy department. So everything we sell is guaranteed fresh, or we'll make it right. Kroger, fresh for everyone.
Get more ways to save at the Buy 5 or More Save $1 each sale. Just buy 5 or more participating items and save $1 each with card. Kroger, fresh for everyone.
Where am I going now? Just falling over dreams. Now I'm just so far gone, this isn't what it seems. Taking me so damn long, it's fading from belief. I need to slow this down, it's burning from beneath. Come break this light, this flows in my eyes. Holding on for what is worth my life. And now inside, I'll make it up the fight. Find my way to giants in the sky. Tonight it comes to life.
Hey everybody, I'm back. Alrighty, slide that down a little. Go. Cool. I think we're probably done with that now. I can close that one out. So we'll finish up exceptions and the bag using linked objects and then project 1. And we should be able to call tonight without going super late. Should be pretty good. And we'll have a little bit of time to practice tonight, or if you're fried, you know, take some of that practice time later. And do read the chapters. Like, we have a textbook for a reason. It is definitely your main reference here. I'm trying to pull out the highlights for you, show you the interesting stuff, kind of explain it in some other words. Hopefully that'll help. The crypto crash may be really sad, but that's okay. We were due for one. We were due for one, and I didn't sell off soon enough, but that's okay. That's all right. we'll get back, probably get back up to previous numbers. I don't know. It's hard to really tell. I don't think any of us small players even make any difference anyway. It's all the really big players in Wales. Probably Married Pizza. I don't know. Like, it's cheaper now than it was last week for sure. Ow, baby boy. Ouch. Okay. Your claws hurt. Your claws hurt. Merlin, you want to say hi again? Is that what you want? You saw me sit down? Say hi. I'm a little cat. I'm cute. Meow, meow, meow. He's pretty quiet. His sister's a lot noisier. She meows really cutely. Yeah, I mean, I don't know. I gotta, not this week, but if it stays, I'm not buying for at least another 2 weeks. Yeah, I'm not sold on Bitcoin, but I think Ethereum and Dogecoin actually, with their interest in moving to a proof of stake rather than proof of work concept, can actually work. And I think that's more sustainable and can move forward. I'm sure some of the other nonsense coins out there can do a similar thing too, but I think having some name recognition really helps as well, just like anything else. Mana, I haven't heard of Mana. Yeah, there's like so many out there now. I feel like you have to know which ones have enough recognition to actually like make a dent. Hey, baby. All right. So let's actually see if we can use our bag array here then, right? And see if it works for us. Because it's not useful to have a class and not test it. Okay, so we can actually do some unit tests here. So instead of actually, what you might have done here for testing previously, you'd say, hey, I want a bag array of type, I don't know, let's do strings. Why not string? Oh, and actually, here, the fun part here, you can just declare this of type bag interface here. We'll call this names equals a new, and then in here you can say it's a bag array of string. And we'll say, I don't know, maybe 10. What is it upset about? Oh, I already have a names thing here. That's right. Okay, I'll get rid of the array list. I was scared that I did something wrong there. Here, let me commit my code too. Why not? Remember, commit early and often. I should demonstrate that. I'm going to give it a commit message here. So this is bag array complete, commit, and push. So the commit is just a snapshot, right? It's just what the folder looks like, the contents of the folder at that point in time. Okay. Hey. Hey. Oh, you're so sweet, baby. Right, so then I've synchronized, so you can go to repository, view on GitHub, and you'll be able to see all of your files out here on GitHub. Right, you can kind of click through and see, here's the ADT bag. You can click through into source and see all the different Java files. They're all clickable and viewable in here. So sometimes copy pasting from here doesn't work so well, so the raw option usually gives you a better copy paste. I haven't actually needed to do that lately, which is nice. I think it's been behaving a little bit better. But every so often you get some weird extra spaces and things when you copy paste. But you can see if you wanted to play with it. Or you can just clone the repository yourself. The only downside to that is you're going to have to keep pulling changes down every week when I make more changes. And you can't commit your changes to my repository because you don't have access. So I'm the only one who has access to make changes to this one. So it's kind of easy to get out of sync. If that's the case. Hey, baby. So they should all be out there. All right. So we got a bag interface of names, and we'll see if we can do some things. So this is how we would have tested before, right? We'd say names.add. We'll add, how about we add Eric? Names.add. Jasmine, names.add. Okay, let me just do a bunch of these here. That's probably enough there. And let's do 8, right? Because I've got 8 to... Actually, no, let's leave it 10 to make sure we only get 8 items back. So 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And I'll add my kids here. I got Joy, Jeb, and Genevieve, Journey, and Jubilee. I can spell my own kid's name, don't worry. And Jack, or Jackson. Okay, and then we would get a new array of strings, so a string array. I don't know, let's just call it result. Why not? Result is names.toArray. And we'll say for string name in result, we'll print out the name and see if we get our names, 8 names back out. So this is what we would have done earlier, right? We'd run it. Buddy. Oh, goodness. Uh-oh. Look at that. We've got an exception here. Oh, dear. Object cannot be cast to class string. Uh-oh. At line 29. Where's line... What names give me string? Did we do this wrong? Let's see. A bag array, to array, gives me a T array, type T, T array new object. All right, now I'm really confused. That shouldn't have happened. Name's not to array. Let's try that again. Make sure we got the right to array. Yep, that's our method. To array. So type string array. Oh, let's put a breakpoint there, see what happens. We're going to run it one more time. Oh, I'm supposed to debug it. Class object cannot be cast to class string. Module base of loader bootstrap. What? ADT bag line 29. Alright, I'm going to put it in debug it here, and let's step into the debugger. See what we can find. So I'm going to step into. Alright, so now I've got my array here, so my variables list. So apparently not everyone did this well enough in 1500. The debugger is fantastic, right? It's going to pause and show you the contents of all of your variables. So this is my current bag, right? It has 8 items currently. It has an items collection with Eric, Jazz, Enjoy, Jeb, Genevieve, Journey, Jubilee, and Jackson. It looks good. And then 2 nulls, right? Remember, we're oversized. We have some room here. So we should be able to go through and make a T result here. We're going to copy them over, right? So T in my result here. Still have type object. Did it not cast? Huh, it should have cast. That's interesting. I stepped too far. Return. What is going on there? Why did it not? Yep, there's that exception. Okay, that's bad. Why is that failing? Alright, so something didn't cast quite right. Take a look here again. So we did the cast up here, right? Just make sure we did it right. T of new object. T array of new object. Type T result. Returns the result. That should match there. All right, I'm confused. Let me make sure we did it the same way. So add, yeah, so add doesn't work for a basic array. You have to use the index notation. But the array list class in the Java ADT, or the Java library, you can use the add method. Let's make sure we copied Mr. Toronto the right way here. My goodness. Let's see. To array. T array. Result, yeah, is a new T array, new object. Number of other items. Copy item over. Run the result. Huh. That is really weird. No, that should work. That's unfortunate. What did we do wrong here? Alright, well that went poorly. It should be a string array. This is a bag of type string. To array. I don't know. I'm going to try casting it. Let's see if we can do one more cast there instead of run. Nope. Can't be cast to the string. Is this something we did wrong? That's really unfortunate, folks. Let's call it an object array. And that's not what we want, but I just want to make sure that this works. Nope. Error, incompatible types. Oh, object can't be converted to string. Sure, object. Goodness. Alright, so it's fine with an object array. That's really weird. Alright, so this with string array. Why it's not. Not sure why it's not. That's really weird. I'll have to look at that after when we're not in the middle of trying to figure this out. That's unfortunate. Oh, little baby fell asleep. Sweet little kitty. Alright. So this is how we would have done some testing before, right? It's not going to... However they do this is not going to work well, is it? No, if this doesn't work, the whole testing is not going to work very well. So we'll get to other testing later. But we want to make sure it works, right? We can get counts of, right? And that sort of thing. So maybe I'll duplicate some of these names here. We can check the count of, let's say, names.getFrequency of Eric. Right? And you'd expect that to be 2. Parentheses there. Right, so you just kind of go through, you'd say, hey, I expect it to be this value. Let's see what it actually is. We get a 2. Right, so that sort of thing is pretty good. You know, let's try it anyway. It might work here. It might work. So we're going to go to our bag array, and what we're going to do, we're going to write unit tests where we don't have to put them in main and rely on ourselves to eyeball it here. So I'm going to right-click and say navigate, go to test. So this is my bag array tests here. You want, if you're doing a Java with Ant project, you want to make sure you're in JUnit 4. The later JUnit doesn't behave with Java with Ant for some reason. So use JUnit 4. You can leave these ones checked. Don't worry about the other check marks here. We'll say OK. It's going to generate a new file in the test package over here called the bag array test. And this is where we can make the computer do that work for us. Hi, baby girl. Ouch. Okay. Ooh. Yeah, you're sharp. So when you do unit testing, right, it's that same idea. We're gonna set up what we need to do the test. We're gonna call the code, and then we're gonna check, did we get what we got back, or did we get what we expected? So there's a convention for that. We call this the AAA format, right? So we're gonna arrange all the variables needed. So we set up all the variables needed to test, including expected results, and then we call the code for testing. Get actual results, and then we assert. Did we get what we expected? Okay, so when we arrange for get current size, we're going to make a bag array of type, I don't know, let's do string, sure, why not? We'll call bag equals a new bag array, type string, sure, we can just use the default capacity, shouldn't matter here. I'm sorry, yeah. So we need the bag to test, so I'm going to put it in a range. Some people think we're calling code that should go in act, but we're not really testing the constructor here. We're going to check to see if we can add an item. So bag.add, we'll just add something, an empty string, or test, why not? And then we'll have an int for expected number of items, or expected current size. And then we'll call the code that we're testing. Should be 1. Stop playing with my cord, it's not a toy. So the code that we're testing is we're going to have an int for the actual current size is my bag.getCurrentSize. And then we'll assert, did they match? So we say assert equal. There's all sorts of really cool asserts. Equal the most common. There's assert true, assert false are also pretty common. But this should work for us. So we're setting up what we need. We need a bag to test. We need to add something to it, and then we have our expected size. We're not really testing the add code here, we're testing the get current size. So I usually leave this stuff in the arrange because it's not the part of what we're testing. What we're testing is the get current size method. Okay, and we can test the same is empty here. So instead of the get current size, we'll have a Boolean for actual is empty and bag.isEmpty. And now I don't need to actually have an expected current size here. And what I'm going to do, I'm going to use that assert. So isEmpty should be false. I'm going to say assert false, actual is empty. So this will say is not empty here for the test. So you want to give your test name a nice meaningful name. And I'm going to test it again here to make sure that I'm getting both cases. So if we don't add anything, we should be able to assert true that yes, it is empty. Remember, in our bag array here, right? I guess there's only one line, so we're getting code coverage either way, but I feel better testing in both directions. I don't know. Maybe that's silly, but I like that. Okay, and then testing, does add work? Okay, well, let's go back here. Let's grab all this. So I don't have an expected current. I guess we could still test a current size, but we're going to have an expected value. So I'll have a string for expected value. Call that one test. And then I'm actually going to move test then into the act section because I'm testing the add method here. We're going to add test, and we're actually going to have a Boolean for the result, right? This is the add result. Remember, that's going to return something. So we can assert true that our add result is true, that we got back success. Yes, we had room for test. Our current size should be 1. And then we also now want to check here, we'll get a string array. Oh, shoot, this is the part that wasn't working with the string array. I don't know why. I'll have to fix that later. So we'll say an object array result equals bag.toArray. And then we're going to assert equal that the expected value matches my result index of 0. Right? That I get back was test the thing in the array that was returned. Right? I'm going through this a little fast, so hopefully you've had a chance to see this before, but I know if you weren't in one of my previous classes, this is all brand new. So happy to chat about it again. I don't want to spend too much time doing all the tests. We don't need to get through all of them here, but I'll leave the other ones off for now. But this is sort of the idea. So we're going to set up, this is what we need to test, including our expected values. This is the code we're testing. So we're testing add, we're going to check the current size, and we're going to get the results back with toArray. Kind of doing a couple things at once. We want to make sure when we added that the size increased, that we got a true result back, and that when we toArray, it's actually there. So this is our only way to check, hey, did it actually make it into the results here? You can right-click and say test file, and you get this really cool test result window. So under window, under IDE tools, there's a test results here, and you can see if they passed or failed. So if they don't fail, they pass by default, which is a little bit ugly. So I think there's a, you call fail. There we go. This is probably more proper here. So until we've written the tests here, we'll say fail for all these. Right? Okay. That ought to do it. So now when I run my tests here, I should get a bunch of failures, which should be good because I didn't actually do anything yet. There we go. So now a bunch fail. Right? All those other ones failed. These ones passed here. So the tests we wrote seem to pass. Right? The test get current size, test get current size passed. The test is empty. Is empty. The test is empty, not empty. And the test add. Let's see, yeah, test add passed. Okay, and the other ones failed. So we're feeling pretty good, and we made the computer do the testing for us. This is unit testing. We're testing one method at a time. Right? Essentially, it's hard to test like add without being able to get the results back and without checking current size. So sometimes it's slightly more than one, but essentially one little chunk of functionality at a time is what we're going to do with unit testing. And the goal of unit testing, the gold standard, is to get 100% of your code run during tests. So right now with add, we never have this line of code running. Baby girl. Oh my goodness, your claws are sharp. All right, you want to say hi too? This is Moxie. Moxie, say hi. Say meow. Not going to meow? Nothing? Gonna wave at everybody? Hey, wave. Hi. All right. Maybe she'll fall asleep on my lap too. So in our current tests, this line of code will never run because we've never filled our bag. right? That internal array storage. So I don't have 100% code coverage. So code coverage is the number of lines, a percentage of lines of code that actually run in your tests. So the goal is 100%. So you want to make sure that every if block, every else block gets included and run. Right? So make sure that eventually we get an if here, eventually we get an if here, eventually we get a false here, those sorts of things. Okay? So that's a good goal. Mr. Chrono does a pretty good job talking about unit testing, but I prefer making Java do it for us. Right? Okay, so that is the array-based bag. Now we're going to do another class here. We're going to look at the bag linked objects. And this one again is of type T, and we'll implement the bag interface of type T. And it says, oh no, I don't implement it because I'm missing it. Yes, please write all the methods for me. Okay. And again, we need a bunch of attributes. We need a private int for number of items, and we need, so now we're not going to use an array though. We're going to store these differently here. We're going to look at a different way of storing, which is really fun. So this concept here is using linked objects where one object knows where the next one is. So Mr. Chrono did a nice job. You can imagine the previous array-based session. He said, well, imagine a classroom with a bunch of seats. And when someone comes in, you say, go to the next available seat, go to the next available seat, go to the next available seat, right? If someone gets up and leaves, you say, hey, whoever's at the end, go take their seat, because you don't want to leave any gaps. That's essentially what we did. But the problem is we run out of space. So we actually skipped over where you can write a resizable version where you have to do an array copy, because I mean, really we would just use an array list. So you can finish that out in chapter 2. Take a look at the resizable bag array, which is pretty cool. So instead of just failing here, when you go to add, it just resizes that internal storage array. So it goes through the items, makes a new items array, and then goes and copies all the ones from the old array into the new array. It's actually not too much harder to do. It works out pretty cleanly. Excuse me. Well, it's all like mostly melted ice now. It is not delicious cokiness. All right, where did I put my book? Here it is. So with the linked object storage here, the idea with this one is instead of just a row of desks and I say, okay, you go sit in this one, you go sit in this one, you go sit in this one, what we do instead is imagine they're numbered, right? And then we've got a number here, but the numbers don't really, we'll just make up the numbers maybe. So we'll say, here, let me put up a whiteboard here. This is worth drawing. So let me clear this out. So I'm going to have an object here. It's going to have the T item, and then it's going to have a next. So next might be null. If there is no next, it might be null here. It's a weird thing there. Okay? So a T item and a next. This we'll call a node. So if you want to add an item here, I'm going to make a node here. So I'm going to track, hey, so I know who my first node is here. So right now next is null. There's nothing in there. We don't have one. So what I'll do, if someone else comes and we want to add somebody, I'll say, oh great, okay, we want to add somebody to our list here. So what I'll do is I'll make a new node. So here's a T node. And I'll say, hey, your next is this one that used to be my first. And now first, hey, you point to the new guy. If I want to add another one, sure, we'll add another T node here. Its next then will be what used to be first, and then my first will change to become this one. So there's never any array resizing that has to happen. What happens, all these nexts here are like a reference to, hey, where is the next one in memory? Remember, all of our references are really just a memory address. So like this is, x237f, and this might be x345b, and this one is null. Right? So I say, hey, where's your next? Who comes after you? Great, here. Who comes after you? Great, here. So if you imagine that classroom example again, what I would do is I would say, okay, when you come in, you're going to get a piece of paper and you're going to write on it who comes after you. The first person in the class, nobody comes after. Right? They're now the first and the last. So they're going to stay the last item, last person in the class. When someone new comes in, I'll say, hey, the person who comes after you is this first person. Write down their name. And you might write down their name and put their name in here, right, or their location, where they are, and then you go sit down. And now I know that you're the first. When someone else new comes in, I'll say, oh, hey, you're now the new first person. You write down where the old first person was. And to follow those links, you have to go through the chain. You have to say, hey, who comes after you? Who comes after you? Who comes after you? Who comes after you? So people can sit in any order that you want, right? So we might put a person over here was first, and then maybe a person over here. And you know that this person comes after you. We put another person in here. This person comes after you, 2, 3, and we add a fourth person over here, right? Maybe you want to sit over here. Person comes after you is this person over here, and we'll add another person, 5, right? We can put these anywhere we want in memory. And what's really cool about that is you don't have to ask up front for a big array size amount of memory. Remember, when you ask Java for an array of size 100 or 1,000 or 10,000, it's chunking out 10,000 spaces in memory to store your items, right? And it's all contiguous memory. And that's why you can jump using array indexes to the 0th item or the 100th item or the 10,000th item. Anywhere you have an index, you can jump because it knows where to find that memory address. With links here, you have to follow the chain. You have to follow the links. And we'll look at a lot of advantages and disadvantages of them next week, which is really cool. So what we're going to do is we're going to use a private inner class. We're going to have a private class called node of type T here. And node of type T then has the T, we're just going to do public T item here. We're going to cheat and make these public because I only have access to them internally here with my bag with linked objects. So I have a T item and then I have a public node next. Okay, and then we can make a constructor if we want here. So public node given a T item and a node next. Right, we'll have this dot item is the item, and this dot next is the next. Next. Oh my goodness, there we go. Okay, and then we'll also, if we want here, we can make another constructor here, node that just takes a T item. We'll call this, given the item, and null. Okay, so if you just have an item and you don't know who your next is null. If you know who your next is, great, you can give it to me right here. So this is our internal private class. This is the internal storage here. Okay, so get current size and is empty are the same. We can copy those. So let me go to my bag array, and we'll copy get current size and is empty. We'll steal those in my bag with linked objects. Okay, and we also need to know here then, we have a private number of items, and we have a private node first. So when you make a new bag linked object, so we'll write our constructor a bag linked object, a bag linked objects. So we don't need to know a capacity up front. It doesn't matter to us. So we'll say my first is null, because I don't have a first. And number of items is 0. Okay? So to add something here, we have two cases. If our first is null, actually it doesn't matter, right? It's the same thing here. So what we're going to do is we're going to take, we're going to make a new node. So we'll have a node, new node, equals a new node, given the item, and its next should be our first. It might be null, it might not be. We don't care, right? If we don't have a first, it's null. If we do have a first, it knows what comes after it. Okay? And then we'll say first equals a new node. New node, and then my number of items, plus plus. And then return true. Okay, so we make a new node. So we're going to store the item in a node. The thing that comes after it is whatever our first used to be. If it's null, it's null. If it's not null, it's the first node. Perfectly fine, right? It's you come after, you come after, you come after. It'll return true. So to remove an item here, this one is fun. So we don't actually want to remove from the back because we want to do this fastly, right? So we're going to have a node to remove, is the first. We probably also do, let's do some more sanity checking too. So let me steal that from our bag array. If we're empty, do the sanity check. Okay. If we're not empty, great, we can continue. Right? If we throw an exception, code stops. The person calling this code has to handle it. So our toRemove is first, and then we're going to say our first equals first.next. So let's say, hey, you're first now, right? So I'm pointing to this example here. I've got this one as my first. First.next is this one. So I'm going to change my first to the first next, and then I can return this value. Okay, and then we'll return toRemove.item. Give them back the item that it looked at. Why is that not a T? Node of T item. Object I might convert it to T. Oh, node of T. There we go. There we go. Node of type T. Okay. So it knows what type it is. toRemove is the first. Okay. Then we can return that item. To remove a specific item. Well, now this is fun. Now this is different. Remember, to look at all of the items in our list, we have to go find them. Right? Start at the first, go to the next, 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 on and on and on and on and on. So we have to see if it's there by asking, hey, go to your next, go to your next, go to your next, go to your next. Okay? So we actually have an interesting first case here. So our first case, we should probably still sanity check here. And then we'll check to see which one we're going to remove. So if it's our first item, we need to do this remove operation here. So we're going to check. We're going to say if the item.equals first.item. If it is, we're going to return remove. We already know how to do that. Oh, never mind. I'm sorry. We're going to remove the thing and then return true. Sorry. I forgot. This returns a Boolean result, true or false, if we had it or not. Okay. If it's not the first item, so I don't even need an else here, because remember, a return stops my code. So there's no else. Right? Else is redundant, because if I returned, it's never going to run here anyway. So I'm just going to keep going without an else here. So what I need to do is I need to be looking at the next item in the chain. So if I have this loop here of 5 people, right? 5 is currently my first, because he's the newest item. Right? If we wanted to remove person 3, to do that, we go to person 4 and we say, hey, I know 3 comes after you. What comes after you should not be 3 anymore. It should be 3's next. So we're going to break 3 out of the loop here. That's how we're going to do that. Okay, so we're going to skip that item in the loop. So I need to be looking at the next. So I'm going to say a node of type T, I'm going to say current is first. And now what I want to do, I want to go loop until I reach the end of my list, or I found it. Right, so this is a little bit crazy here. So we're going to loop, we're going to say while current.next does not equal null. Right, as long as you have a next item, we can keep on looking, because I know you're not the first. Right, we're going to look at the next item, and the next item, and the next item. So if current.next.item.equals the item, oh goodness. So if your next item is the item, we want to remove you. Yeah, don't buy followers or viewers, of course. Long range missile. That is solid advice, my friend. Solid advice. Okay, so if your next item is the item we're looking for, we want to remove that one. And to do that, right, remember we need to jump it. So we're going to say, hey, your next, so current.next needs to change. We need to jump over it. It needs to be current's next. That might be null, and that's okay, right? If you're the end of the line, if you're the number 1, right, and we want to remove number 1, its next is null. That's okay. We're all good. We're just jumping it out of the list here. Okay, and then we're going to return true. If we've gone through the entire list and our current next is null, So if we get to number 1, current's next, we don't have a next here. We're done, we didn't find it, we're going to return false. Excuse me. All right, clear. Now this one we can actually do a little faster here. We just say first is null. And we set number of items equal to 0. So if first is null, we no longer have this reference here. We no longer have this person. The garbage collector will take care of that. And if we don't have the first one, we don't have a reference to the next one, or the next one, or the next one, or the next one. The garbage collector will take care of all of them. It's fantastic. So get frequency of, okay? Similar idea here. So this time, we don't need to be looking at the next. So we can say, we'll have an int for frequency is 0, and we're going to say in node of type t, current equals first. And we can say while current does not equal null. Let's loop. If current, current.item dot equals the item, take my frequency plus plus. Oh, I missed a step. Folks. So if we find it, right, if it matches, great. If we didn't find it, now current needs to move to the next one. So current becomes current's next. And we have to do the same thing here. That's right. So if it's not the match, current equals current.next. Right, this moves the pointer. So as we're looking here, so right, if we have this list of 5 here, okay, so our first is currently at 5, and we say, hey, let's remove person number 3. So current starts at first. First's next is not 3. So now current moves to current's next. So now current points at 4. We say, hey, is your next 3? Yes, it is. Okay, so jump it. My next becomes the next. Jump. We're done. Right, with our get frequency of, we're saying, hey, current is 5. Are you what we're looking for? Are you number 2? No. Go to next. So now current is this one. Are you number 2? No. Go to this one. Are you number 2? No. Go to this one. Are you number 2? Yes, we found one. Go to the next one. Are you number 2? No. Go to the next one. Oh, we're null. We're done. So linked objects are fantastic. So when we're done, we're going to return frequency. All right, we're going to do the same similar thing here with the contains a item here. But as soon as we find one, we're going to return true. If we've gone through an entire loop and we haven't returned true, we're going to return false. We haven't found it. All right, and then to turn ourselves into an array, let's try this again. I feel like something's not going to work right for me, and I'll figure out why later. We'll say this is a T array. Result equals a new object array of number of items. And we have to cast that as type T, as a T array. T array, my goodness, missing all the buttons here. And then we'll say for index is 0, index is less than number of items, index plus plus. Now this one's tricky. So we need to start with current. So we're going to have a node of T is our current here, equals first. So start with first. Okay, and let's start looping. So we're going to take the result at index equals current.item. Then current.item, current needs to move to current.next. Okay, and then index will update. So then we'll be at index 1. Take the current item. Go to the next one. We're at index 2. Right? We're sort of doing this update in, it's sort of this process here. Right? The index plus plus and current equals current next. We're walking. When we're done, we'll return result. Okay, and now what's cool is if we do tests on this one, let's go to navigate, go to test, and okay. Did that change wrong? Static or unit? No, that should be fine, right? Let's take a look at our bag array test. Yep. So all of these tests should essentially be the same thing that we wrote. Here, I'm only going to do a couple of them, right? Up through add. But instead of bag array, I'm going to do a find and replace here. I want this to be the bag linked objects. oops, bag linked objects. So I'm going to replace. All right, awesome. That was it. That wasn't too bad. And now these tests should, because they should do the exact same behavior, right? We just are using linked objects behind the scenes. Let's see what we get. And they pass. All right, look at that. Let me go copy over those failing tests too. Now I feel bad. So we can feel pretty good that it did what it's supposed to do. And run the tests. All right, and we get add works, get current size, is empty, and is empty, not empty. All right, so add seems to work. We haven't tested the remove stuff yet. We'll get to all that and make sure it all works. But how are you folks feeling so far about our bag ADT? Whether or not it's an array-based or linked objects-based. I know linked objects is brand new. It's going to be a little bit, and we'll talk about it again next week as well to kind of talk about this topic again. How we use this internal node, and node knows what the next node is in the list. Should it be a node of type T too? Maybe that should be a node of type T. Probably doesn't matter. Maybe it matters. Okay, and again, we can also then go use it in our ADT bag, our class here with main as well, right? We do the same thing, make a bag of linked objects. Of type string, maybe, and we'll call this one linked names. This new bag of linked objects. And we'll go through and add a bunch of names again. It's linked names. And then we'll go through and print all those out. Let's see, results can be linked names to array. We'll go print them all out, make sure we get them out again here too, just for fun. Ooh, now, oh, see, our order's different here. That's, oh no, I have Eric in here twice, never mind. Is it different? It is different. Where's our output? Yeah, the order's backwards, right? Here, because when we add something, we're adding it to the front. Here, so that's, and it shouldn't matter because the bag doesn't guarantee order. Remember, the bag says the order doesn't matter. When you remove something, we're just swapping with whatever's at the end. Or that was with the array-based, actually. With a linked-based, it's going to remove from the front. All right, you folks okay so far? Okay, so here's what we're going to do. For our first project, we're going to use this interface, the bag interface. So we're going to write a class that accepts a type of bag interface. So you don't need to know whether or not it's an array-based bag or a linked objects-based bag. You just know you get something that fits this interface mold, and we're going to implement it. Okay? So let me come back to D2L here. We'll go to assignments. I'm going to make a new project 1. Now this is due in 2 weeks, so that's June 2nd, 6 p.m. Okay, let me make a new grade item. All right, so this is using the bag interface, bag array, and bag linked objects. Let me commit all that here. So this is our bag linked objects and tests. Create a shopping cart application that accepts a type of interface in the constructor. So the constructor for shopping cart, right? Shopping cart. Shopping cart. Your shopping cart class needs to accept a bag interface as the bag. Right? It doesn't need to know which one it is, but we're going to actually test it with both. We're going to try it out with both later when we get there. Right, so to do that, right, when you write a class here, Let's do another class, like shopping cart. Right, it's going to have a bag interface, bag, and then the constructor, right, public shopping cart, takes a bag interface called a bag and sets this bag to the bag. Right, so then everywhere else in my code, right, if I have like an add item, void add item, you know, item, sure, why not? We'll say bag.add, and we can add the item. Because bag has a method called add. It doesn't care what it is. Does that part make sense? How it's going to accept a bag? Oh yeah, we don't have an item, sure. Let's say string for now. Bag interface. It should be of type item. Yeah, we don't have item. Sorry, I don't have an item class. We got to write an item class. Yeah, okay, which is real fast. I wanted that to compile. Done. Okay. Okay, so you're going to use the bag interface where it doesn't need to know which one it uses, and then we're going to test it with both. We're going to try it out with both. Okay. GitHub repo, for example. Okay, so with the console application, we're going to create a menu that allows the user to add an item to their cart, remove an item, remove a specific item, a count of number of items, get rid of the cart, abandon the cart, abandon the cart. Let's see, that's new items, removing, adding, yep. So when adding an item, or we have to write the item class, include a name and price. Adding an item, ask for the name and price. Add that to the bag. So the item class includes name and price. Add a equals override method. That returns true if the name and price match. Remember the default equals override? Sorry, I don't need to hit Control S all the time. But the default equals is going to check if it's the same memory address. We want to say, hey, if this is barbecue chips at $1.50, great, barbecue chips at $1.50, they should be equal, regardless of whether or not they're the same one in memory, because we need to be able to remove items from the cart. Okay, remove a specific item, just grab something off the top, sure, go for it. Add that to the item, when removing, we'll ask for the name and price, and remove it. Tell them if it was successful or not. Right, it was successful or not. Remember, our array-based bag, we didn't make it resizable yet, and that's okay. So if it's not successful, tell them they already have too much stuff in their cart, they can't do it. With the linked objects-based one, we're never going to run out of space. I mean, eventually the system could run out of space, and the operating system will tell Java, no, there's no more room for nodes. But the odds of us having that many items are relatively low for our examples. We're not doing millions and billions of anything, so we should be fine. We're never going to run out of space with our linked objects. Okay, removing an item. If removing any item, tell them what was removed. And then add a method for getting the total cost cart. Add a method for printing a receipt. IEPT? That doesn't look right. Receipt? Each item, and cost, and total cost at the end. Okay, how's that sound? Does that sound relatively straightforward? So I need to give you the link though. So submit the URL to your feedback pull request. Hey, thanks so much for cheering. 1 bit. All right. Yeah, seems good. I like it. Pull request. Let me give you that link here. I need my classroom GitHub here. Pull it up here. This is project 1. Okay, and then we're going to try it out using both types of bags, array based and linked object based. So in your code that actually runs this, we'll make one shopping cart that uses an array-based one, we'll test it out. We'll make another shopping cart that uses the linked objects-based bag and test that one out as well. Okay, so you're going to submit a URL to me. And I'm going to add a rubric for you here in just a second. Let me grab all this. So never, it's up here. There we go. It takes you to different pages. It's really obnoxious. So submit the feedback request and a self-assessment using the rubric. Whether or you got each point on the rubric. So I'm going to add a rubric here, and you need to tell me whether or not you got the points for it. So this is your last check. I write these rubrics, and I find that people don't often use them all the time, and then they're confused about how they scored or what went right, what went wrong. So go through the rubric yourself and score yourself. Tell me whether or not you got this thing or you didn't get this thing. Oh, buddy, you're falling down? Hi, Merlin. So if it's complete, you get the point. If it's missing, you don't get the point. Right, so go through and self-assess yourself and tell me whether or not you got the points or not. Okay, so the shopping cart class accepts a bag interface T object in the constructor. That's like a free point right there, right? I kind of wrote that one for you. Okay? So then shopping cart. This can add an item and returns the result, or displays the result. And can remove an item, displays the results. Remove random item and displays the results. It can give total cost of cart. Can display itemized receipt. What else do we have here? Receipt, total cost, removing item, removing, adding. Oh, that's right. Item class. Item class. Name and price. Private attributes. Item class, the equals method override. And then, so this tests here, this is fine if you just want to do it in main. I'll show you more of the unit tests again. I'll probably require those for the project 2 here. So test the shopping cart with a bag array in a main method or unit test. Right. We'll try it out, make sure it works. And then, oops, does it again with the bag linked objects. Okay, so I got 10 points there overall for the project. Got 2 weeks to work on this one. We got a little bit of extra time tonight. And don't forget you can schedule time with the tutors through the Academic Support Center. Mr. Tim is fantastic. And Rika is also tutoring as well now. She's on the list here. So you can take a peek at the syllabus. I got a link to the Academic Support Center. Oh shoot, that should be 6 p.m. My time's wrong. Edit. 6 p.m. Not 11. How did that change? 6 p.m. There we go. So click the link. It'll create a repository for you called Project 1 with your username. If you're also in the 2151 class, you probably already have that repo because I'm not making extras and extras. So you can just make another project in there. It should be fine. Okay. Where's our syllabus here for that link? I think I've got everything up to date here. I'll get that 2 array fixed in a little bit. I'm not really sure what's wrong with it since this shopping cart and item stub. I'm not sure what's going on with that to array. I'll get that fixed up later tonight for sure for you folks. Where's our syllabus? Here we go. So the Academic Sports Center, you can find that link here in the syllabus for tutoring. Somewhere in here. Where is it? Here we go. So this is free of charge. It's paid for through your tuition and tax dollars, which is fantastic. So take a look at the Orchard Ridge schedule. Get in contact with them. Mr. Tim or Miss Rika are amazing, and they can get you sorted out here. Right? She does tutor for $23.53, and Tim tutors for everything. So they've got some individual slots as well. I've got my standing office hours Monday and Wednesday, 3 to 4:30, and 10 to 11. If you want to book an appointment with me, let me know, or just shoot me a message. I'll be around. Should get a quick response anytime those hours. If those times don't work, feel free to reach out and suggest some other times to me, and I'll see if I can make one of them work. Okay? Yeah, this is technically through the Orchard Ridge campus. Yep. So that's why there's an O here in the section number. O for Orchard Ridge, A for Auburn Hills, H for Highland Lakes, R for Royal Oak, and S for Southfield. You see different letters there in your section numbers. All right, folks, it's been fun. That's all I've got for you. So I'll post the recap. Yeah, actually, I am taking over for Alan when he retired. So I have officially taken his... No, I took Bill Schanenberger's spot. Alan retired. The new guy who's starting in September is going to take over Alan's old spot. Yep, 2151 has study group on Thursday nights. Sure does. 5 to 6 for study group, Professor Perp. All right, folks, let's see if there's anyone fun around to raid here. Let's see what we can do. I'm going to put on my ending screen because it works a little better here for me. So we'll put the stream ending screen on here. See if we can go raid somebody. Yeah, you can use that work, or you can use the examples from the text as well, whichever you prefer. Not a big deal, one way or the other. Oh, let's go check out some chess. We got to go watch some chess. All right, folks, it's been fun. Stick along for the raid if you're up for it. It's just a fun Twitch thing to do. If not, take care, and I'll see you next week if I don't hear from you sooner. Take care, everybody. Thanks.